Hi, my name is Car, and right now I'm going to be talking about the differences between the goodness of fit and the chi-square test. So, when I was studying for this exam, I struggled a lot because I didn't really understand the difference because they look very alike. But the difference between the two is that the goodness of fit uses one categorical variable made up of two or more groups, and the chi-square uses two categorical variables made of two or more groups. So that's the difference. It's just basically one sample, two sample, but they give it fancy names for some unknown reason. Regardless, I'm gonna go over both of them step by step, starting with the goodness of fit, and explain what you have to do with an example. So let's get into that. Alright, so I wrote down an example. Dogs come in all sizes, and it's found that 30% of dogs are small, 45% are medium, and 25% are big. We want to check if this is correct by looking at 1,000 dogs. I figured if we're going to talk about goodness of fit, we might as well talk about the goodness of boys. So we have now this table. How do we fill this in? Well, we're first going to look at our expected scores. How do we get those? Our expected scores are basically our probability times our n. Our n is 1,000, and we can see our probabilities over here. So the probability for a small dog would be 30% times 1,000, which is 300. 300. So we expect 300 of our good boys to be small. Same with medium, which is 45 times 1,000 is, well, it's like 30 times and 45 times 1,000. It is 450, and big, the probability is 25 times 1,000, which is 250. So that's our first step done. We now know how to get those. Remove this. Then, like always, our first step now is going to look at our hypotheses. And our null hypothesis is that our observed value is going to be the same as our expected value. Like, we assume that we're going to observe just as many as we expect. So, expect. Meanwhile, our alternative is that we are not going to observe what we expect. So, let's see. We did our sample, and I'm going to give you guys the results that we found. So we found 260 small dogs, we found 500 big, like medium dogs, and we found 240 big dogs. Now let's calculate our chi-square. How do we do that? Well, the formula for chi-square is sigma observed minus expected squared divided by expected. And that, we all add those up together, and that's how we get our chi-squared. So let's make some space and calculate our chi's. So for the small dogs, we observed 260 minus 300, and we square that, and we divide it by our expected. 300 is 5.33. Perfect. Now let's move on to the medium dogs. where we observed 500 whilst we expected 450. Square that divided by 450 is 5.55. And lastly, the big dogs. It is 240 minus 250 squared divided by 250, which is 0.4. Well then, now we have to put those together because we had the sigma in front of it, which is 5.33 plus 5.55 plus 0.4 gives us a total of 11.28. Now what to do with that? Well, we have to find our degrees of freedom. What are our degrees of freedom in the goodness of fit test? It's literally just the number of groups. So groups minus 1. Seeing as we have 1, 2, 3 groups, our degrees of freedom here is 3 minus 1 is 2. And now we're going to look at a different table than normal. So we're going to look at our chi-square, which is our F table. And we see what we have our degrees of freedom being 2. So we're just going to look up until we find our value. We see that we would fall between, the P would fall between 0.005 and 0.0025, which is smaller than our expected 0.05 alpha level. Therefore, we're going to reject the null and we're going to assume that there is a difference between our observed and our expected values. And that is everything for the goodness of fit test. And now we're going to move on to the chi-square, which is a lot more work, but it does kind of boil down to the same principle. Now we're going to look at our chi-square test. So now we have two categorical variables. We have the question, how many cubes of sugar is associated with tasty tea? So one of our categorical variables is the amount of tea, like amount of cubes. So 1 cube, 2 cubes, or 3 cubes. And the other categorical variable is if people say it's tasty or not tasty. Well, we observed that 60 people said that 1 cube is tasty, 135 said that 2 cubes are tasty, and 105 said that 3 cubes were tasty, with a total row of 130. And we also found that 30 people said that 1 cube is not tasty, 40 said that 2 cubes were not tasty, and 30 people said that 3 cubes were not tasty. So that gives us our row totals and our column totals. So these two together makes for 90, these two together makes for 175. These cubes together, like these two together, make for 135. All of these together makes for 300. All these together make for 100. And all over we have 400 people in our sample. So let's get started by getting that expected. In our goodness of fit, it was literally just that percentage times our n. Well, we can't do that percentage anymore because we have more variables. So what do? Well, we find the expected by taking our row total and we times that by our column total, and we divide that by our total, which is the 400. So let's go and find every single one of these expected values. All right, so we want to find the tasty for 1 cube. So that will be row 300 times column 90 divided by 400 is 67.5. So our expected value is 67.5. All right, now let's move on to 2 cubes, which is the total, which is 300 times 175 divided by 400 is 131.25. So 131.25. There we go. Now let's move on to the 3 cubes. So that is 300 times 135 divided by 400 is 101.25. 101.25. Now let's move on to the not tasty section, which will be 100 times 90 divided by 400 is 22.5. 22.5. Then let's move on to the next ones, which I didn't write down for some reason, but it is 100 times 175 divided by 400 is 43.75. 43.75. And lastly, we look at 100 times 135 divided by 400 is 33.75. 33.75. There, now we have everything we need to do our chi-square test. Let's see. Let's move this. So we already did the chi-square test with the goodness of fit test, and we're basically going to do that again because it is the exact same formula. It is the observed, like the sigma of observed minus expected squared divided by expected. And we have to do that individually for every single one. So let's get started with our expected for 1 cube and tasty. That is 60 minus 675. Square that divided by 67.5 is 0.833. So 0.833. Let's go to the next one, which is 135 minus 131.25 squared divided by 131.25, which is 0.107. 0.107. The next one is 105 minus 101.25. Square that divided by 101.25, which is 1.138. 1.138. Then let's move on to the not tasty section, which is 30 minus 22.5. Square that divided by 22.5, which is 2.5. Then this one is 40 minus 43.75 squared divided by 43.75 is 0.321. 0.321. And lastly, we're going to go for 30 minus 33.75 squared divided by 33.75, which is 0.4166. 0.4166. There we go. Now we have everything that we're gonna need for our chi-square, because we have said that it is the sigma, so we have to add all of these together. So that is 0.833 plus 0.107 plus 0.138 plus 2.5 plus 0.321 plus 0.4166, which makes for a total of 4.315. Now what do we do with this? Well, we have to find the degrees of freedom yet again. How do we get the degrees of freedom? We look at our total, like the total groups of our row, so total number of rows, minus 1, and we times that by the total number, total number of column, minus 1, and that is our degrees of freedom. So if we look at this, there's 1, 2, 3, so that is 2, times 1, 2, minus 1 is 1, so that is a degrees of freedom of 2 total. Now let's look this one up in our F table. Well, we can see that a 4.3 will fall somewhere in between those. So our p-value will be between, let's see, between 0.15 and 0.1, if we're going to assume that our alpha level is still 0.05. Our alpha is smaller than our p, so we do not reject the null, and we assume that there isn't a big difference between the observed and the expected values that we have observed and all. And that is everything for the chi-square test. It is a lot of little steps, but the chi-square and the goodness of fit basically boil down to the same thing. It's just the one sample versus two sample idea, like one categorical variable versus two categorical variables. There's a lot of little steps that you can trip up on, so just try to keep that in mind. Try to go over a few examples of these. I actually find these some of the more fun ones, so even though at first I didn't get them, but I would just suggest grab a few tables, see if you can find it, try to memorize all of the steps, and yeah, good luck. I hope this helped.